In the last class, we have seen how to assign one structure to other structure. Today's class will concentrate on how to compare two structure variables. Now, if you observe, this is a structure and this structure is associated with two variables A and B. Now, what will happen? A block of memory will be allocated, say, for the variable A. And what is the first field you have? Name. Name takes how many bytes? 10 bytes. So, 10 bytes of memory will be allocated for the variable name. And then marks is of type integer. So, 2 bytes for marks, and average is of type what? Float. So, what is the size of a float? Size of a float is 4 bytes. So, 4 bytes of memory will be allocated, and the name given to these 4 memory locations is nothing but what? Average. So, here I write average. Now, memory is allocated for the structure variable A. On similar lines, memory has to be allocated for the structure variable B also. So, a block of memory is allocated for the variable B. What is the first field here? Name. 10 bytes will be reserved for the variable name, and then you have int marks. What is the size of integer? 2 bytes. 2 bytes for marks. And then float average. What is the size of a float? 4. So, 4 bytes will be reserved, and the name given to those memory locations is nothing but what? Average. So, thus memory is allocated for the structure variable A. Memory is allocated for the structure variable B also. Now, look here. This is another structure. The members of this structure and the members of this structure along with the type, they are same. But because this is a separate structure definition, this structure is totally different from this structure. So, here memory has to be allocated for C, and then memory has to be allocated for D on similar lines as the memory is allocated for A and B. Now, let us see how to compare two structure variables. Now, A is one structure and B is another structure. What is the operator that is used to compare two variables? We use a relational operator. So, here I can write A greater than B. But remember, if A is an integer or float or character or double, similarly B is int, float, char or double, then this relation can be used between A and B. But here A is a structure and B is a structure. It is not possible for us to compare two structure variables like this. So, if you write A greater than B, it is an error. Similarly, if I write A less than B, it is an error. A equal to B or A not equal to B, all are relational operators between A and B. So, we say this operation is invalid. We cannot compare two structure variables either of the same type or different type. So, point number 1 is comparing two structure variables of the same type or dissimilar data type is not allowed. We cannot compare A and B using any of the relational operator such as greater than, less than, equal to, not equal to, and so on. So, these are all invalid ways of comparing two structure variables. Okay, now the question is how to compare the two structures. So, here we write the members of two structures can be compared. The structures themselves cannot be compared, but the members of two structures can be compared. If the type of members are int, float, char and double. Now, if you observe name is an array of characters, it is a string. This is also a string. So, we cannot use greater than, less than, equal to, not equal to compare two strings. So, here the members of the two structures can be compared if the type of members are what? Int, float, char and double. For example, the members of two structure variables can be compared using what? Relational operators. Now, look here. I say C dot marks. Marks is of type what? Integer. So, C dot marks can be compared with D dot marks. So, here type of this field is integer, type of this field is integer. So, definitely we can compare C dot marks with D dot marks. I can say C dot marks greater than D dot marks. On similar lines, Now here, what about average? It is of type of float. Here also we have average, but this average, it is with respect to which variable? D, and here this average is associated with the variable C. So here I can write C dot average less than D dot average. So here I can use any of the relational operator such as less than or equal, greater or equal and not equal. So definitely this is valid. So I repeat, the members of two structure variables can be compared, whereas two structure variables, they themselves cannot be compared. Okay. Now let us see how to perform some of the arithmetic operations on two structure variables. Now here, as usual, memory is allocated for block A, for name 10 bytes, and for marks 2 bytes will be reserved, for average 4 bytes will be reserved. Similarly, for the variable B also 10 bytes for name, 2 bytes for marks, and another 4 bytes for what? Average. Now here our intention is to perform arithmetic operations on two structure variables. So similarly here, memory is allocated for the variable C, and another set of blocks will be allocated for the variable D. Now if I take A plus B, A is one structure variable, B is another structure variable, two structures variables I cannot add, so it is an error. Similarly, I cannot write A into B, it is an error. A slash B, it is also an error. What about A star B? It is also an error. So arithmetic operations cannot be performed on two structure variables. So here I write arithmetic operations on two structure variables of the same type or dissimilar type is not allowed. For example, these are all wrong ways of adding two structure variables. Now the question is, the arithmetic operations, if I want to perform arithmetic operations, how I can perform arithmetic operations? That can be done on members of a structure if the type of member is int, float, char or double. Now here, so the members of a structure can be manipulated by using expressions and operators. For example, here what is this structure variable? The structure variable associated is what? C, and here what is the variable we have here? D. I cannot write C plus D. Remember, C plus D is not allowed, but we can perform arithmetic operations only on members of a structure if they are of type what? Int, float, char or double. Now here we have this field, which is the name of this field is what here? Marks. It is of type integer. What about this field? It is float. So arithmetic operations can be performed on these two members. So here I can write plus C dot marks, or I can write C dot marks plus plus, or I can say C dot marks plus D dot marks. So this is okay, this is also okay. But what about this? I can say C dot marks plus D dot marks. So the members of a structure can be added provided they are of int, float, char or double. So here I can write C dot marks plus D dot marks. It is valid. Okay. So I hope we know how to perform arithmetic operations on two structure variables. Now similarly, here I can say C dot average plus D dot average. So here also this is also okay. So they are all valid arithmetic operations that can be performed on members of a structure. Okay, now let us see what is a pointer to a structure. I think in the earlier classes a brief introduction is given to pointer. In detail, what is a pointer, how to operate on pointers, all those things we study in the next chapter. Now briefly I will explain what is a pointer to a structure. Now here look at this. We have name field, which is an array of how many characters? 10 characters. We have marks, it is of type integer, and then we have average. name of 10 is of type what? Character, marks is of type integer, then average is of type float. So all these variables I enclose within braces like this, and here I write struct. Remember what type of structure it is. There is no tag here, so it is tagless. There is no type def here, so it is not type def, it is not tagless. Now the moment I write type def here, it is type defined structure. The moment we write a type defined structure, here at this point we have to write the ID, student. Student is the new data type, and this ID must end with a semicolon, so here I write semicolon. The moment I define a structure like this, remember memory will not be allocated. But if I write a variable a which is of type student, and here I end with what? Semicolon, this is the syntax. Now by looking at this, compiler will allocate the memory for the variable a. Now here what is the first field here? Name. Name is of, it is an array. Array of how many characters? 10 characters. So 10 bytes will be reserved for the variable name. And marks is of type integer, 2 bytes for marks. And here we say float average. When I say float average, tell me how many bytes should be reserved here? 4 bytes should be reserved here. And what is the name given for these 4 memory locations? If you look here, the name will be what? Average. So that's how the memory is allocated for the variable a. Now if I write, suppose 1000 is the address of the name, and then we have 1010. This is 1000, 1001, 2, 3, 4, 5, 6, 7, 8, 9. So naturally address of this will be 1010. This is 1010, this is location 1011, so this will be 1012. Okay, now I use one more variable, say p. P is of type student, and here I end with semicolon. Now what will happen? Another block of memory is allocated for the variable p, and name takes how many bytes? 10 bytes, and then 2 bytes will be allocated for which variable? Marks, and 4 bytes will be for what? Average. Now if you observe, the size of the structure p and the size of the structure a remains the same. Now what I do? I will slightly change this. So here instead of writing p is of type student, I prefix star here. The moment I write star in the beginning of this, it means p is not a structure variable, instead p is a pointer. The moment I write star, it means p is a pointer. If p is a pointer, this much memory will not be allocated, so that memory will not be allocated. Instead, because p is a pointer, 2 bytes of memory will be allocated for the variable p. And p is a pointer, it means p should contain address of a memory location. Now tell me, here have you stored any address here? No. So in that case, p will not contain valid address, instead p contains invalid address. So if a pointer variable p contains an invalid address, we call it as a dangling pointer. So here p is what? Dangling pointer, because we have not stored the valid address into p. This is just a declaration. It indicates p should contain address of structure variable. Now, so here suppose the address of this memory location is say 0988. Okay, now if you observe p equal to, I will write p equal to what? P is a pointer. Because it is a pointer, it should contain address. So here I write ampersand. Ampersand means what? Address. Address of what? Address of a. So here a is of type student, p is a pointer to student, so p should contain address of a structure variable such as a. So here I write p is equal to ampersand a, and I end with the semicolon here. Okay, now here because p contains address of a, earlier p does not contain any address, now p contains address of this. So here if you observe, I use one arrow mark. This arrow mark indicates that p points to this structure, or p contains address of this structure. So I hope you understood what is a pointer here. Any variable, if it contains address, we call it as a pointer. Now the variable p contains address of the structure, so we say p is a pointer. Okay, now, so in the following program segment, this is the following program segment. In the following program segment, the variable p holds the address of a structure variable. The variable p, if you observe, it contains address of a structure variable. This is the pictorial representation. P contains address of this structure. So the variable p is pointer to a structure. This p is pointer to a structure because p contains address of this structure, so we say p is a pointer to this structure. Now let us look into the definition. A variable which contains address of a structure variable is called pointer to a structure. For example, in the following program segment, the variable p holds the address of a variable, so the variable p is called pointer to a structure. I hope we understood how to initialize a pointer. Pointer, remember, always it should contain what? Address. How you denote address? Ampersand we write. Now here, now tell me what the variable p contains. The variable p contains address of a. Now I don't want address of a, I want a only. In that case, here I write star. I repeat, if I write p, what p means? Address of a. I don't want address of a, instead I want only a. To get a, you have to prefix with what? Star here. Because we have prefixed star to p, for ampersand a also we have to prefix a star. Remember, whenever star and ampersand are associated, immediately after star, if you have ampersand, this star and ampersand gets cancelled. So if it gets cancelled, okay, so instead of writing star ampersand a, what we can write? Star and ampersand gets cancelled. What we get here? A. That means a and star p, they are one and the same. If I write address of a, that is different, but a and star p, they are one and the same. Now I write, instead of just declaring a here, let me initialize the structure variable a. So here I write RAM 25, 24.5, and all these initial values must be enclosed within braces like this. So what will happen here? RAM will be copied into this field because it is a string. String always ends with what? Null character. And then here what is the next data we have? 25. The 25 will be copied into this particular field. Next, what is the next one we have? 24.5. The 24.5 will be copied into this particular field. Now we know how to initialize a structure. Now let me slightly change here. Instead of initializing normal variable, let me use initialization for the pointer. So here what will happen here? RAM will be copied to this location and 25 will be copied here, and then 24.5 also will be copied here. So as we initialize structure variables, we can initialize pointer variables also, because now can you tell me why all this data has been copied into this A? Because P contains what? Address of A. So I hope you understood how to initialize the structure members using the pointers. Now the question is how to access the members of a structure. We have already seen how we can access the members of a normal structure variable. The normal variable is A. Using this A, how you can get this name? RAM. I want to access RAM using the variable A. Remember, the name given for these locations is what? Name. So to access this field, I can say A dot name. How you can access this 25? Using the variable marks and A, you can write A dot marks. What about this data 24.5? You can access using A dot average. So here I write, using dot operator, definitely we can access the members of a structure. And another one is using dereferencing symbol, that is a star and dot. by combining star operator and dot operator also we can access the members, provided we have a pointer. So if we have a pointer, using that pointer also we can access something like this. This is called arrow operator. It is also called the selection operator and arrow operator. Now let us see how to access the members of a structure using the dot operator. Now look here. What is this? A is a structure variable. So if I write a dot, I can access a name, I can access marks, I can access average also. So if I write a name, it means if I say a dot name, I get what here? Ram. And that I have to display. So use the format specifier percentages and I write printf. Now the output will be, if I write printf percentages a dot name, what is a dot name here? Ram. Ram should be displayed using which statement? Printf. So here if I execute this statement, the data is read from the memory and that will be displayed onto the screen. And next, suppose, now here, what is the syntax to access the members of a structure? The syntax is, first you should have the variable. Look here, we have the variable. That variable has to be followed by what? Dot. So variable is followed by dot. In turn, it has to be followed by name. So here we write variable dot member. Now tell me, using the variable a, how you access this 25? This 25 name given for these two locations is what? Marks. So here I can write a dot marks. How you can display a dot marks? Using which format specifier? I can write percentage d, and here I use a printf. Now tell me, if I say a dot marks, what is a dot marks here? 25. 25 will be sent to the output device using printf function. So what will happen? This 25 will move here and this 25 will be displayed onto the screen. After displaying 25, I want to display 24.5. Now can you think of how you can access 24.5 using the variable a and using the field name average? So first you have to write the variable a. So I write a followed by what operator? Dot operator. Immediately after dot, here what we have here? Average. So I write a dot average. If I write a dot average, now tell me what data is read from the memory? 24.5 is read from the memory, and let us display. To display, what is the format specifier we use? Percentage f is the format specifier we are using, and so we have to inform that this a dot average value should be displayed in which format? Using the floating point number. So let me use a printf here. If I use a printf, the data 24.5 is read from the memory and that will be displayed onto the screen. So we have displayed RAM, then we have displayed 25, and then we have displayed 24.5 also. So I hope you understood how to access the members of a structure and how to display using which operator here? Dot operator. Okay, now how to access the members of a structure using star and dot operator. Okay, now let us see here. Here I write star. Now tell me how you access this field. Using a, we can say a dot name. Earlier I told in place of a, what I can write? Star p. So here I write star p and a, they are one and the same because p contains address of a, so star p means a. So here star p means a, followed by what? Dot, followed by name. So here we use how to access the members of a structure using star and dot operator. But if we use a star operator, that star p must be enclosed within a parenthesis, then only you have to write a dot name. Now how you print this onto the screen? Using which is format specifier? Percentage. Yes, I have to use a printf statement. Now what will happen? This data RAM is read from the memory and it is displayed onto the screen. So in place of star p, what I can write? A I can write. In that case, you can write here what? A dot name, A dot marks and A dot average. Instead of writing A here, we know A and star P are one and the same. So what I can do? In place of A, what I can write? Star P I can write. So the syntax to access the data members of a structure using star and operator is, first you have to write star variable, star followed by variable within the parenthesis, then followed by dot, followed by member. So here we write star P must be within parenthesis, followed by dot, followed by name. Similarly, what about here? A. In place of A, what I can write? Star P, but only thing is star P must be enclosed within parenthesis as shown here, rest remains same. Now, if I execute this, what will happen? 25 will be sent to the output device. Next here, star P dot average. So what is average here? 24.5. That is read and that will be converted into floating point number and that will be sent to the output device. So here this 24.5 will be displayed onto the screen. So I hope now we know how to access the members of a structure using star operator and dot operator. Now another way to display or to access the members of a structure using selection operator. When I say selection operator, we use arrow operator. Now here I write P arrow mark name, P pointing to this name. What is P pointing to name means? It is RAM. So if I write percentages and printf statement, what will happen? This RAM is read from the memory and that is copied into the, or it is sent to the output device. Now tell me, using this arrow operator, as we access a name on similar lines, can you tell me how you access this marks field using the variable P? The name can be, this field can be accessed using P arrow mark name. On similar lines, you tell me how you access this data using the variable P and marks. So we can write P arrow dot marks. Now let us see what is syntax of using the selection operator to access the members of a structure. So here the syntax is, look at this and tell me what is the syntax. This P is what? Pointer to a structure. So variable, this variable must be pointed to a structure. It has to be followed by what? Arrow mark. So here I wrote arrow mark. It has to be followed by the member. Okay, I hope you understood how to access the members of a structure using pointer variable. So either you can use arrow mark like this or you can use the combination of star and dot operator. Now here I will use this syntax to access the data members of a structure. Now you tell me how you access 25 using the variable P but using arrow mark. So here I can write P arrow mark marks. If I say P pointing to marks, we read something like this. P pointing to marks. P pointing to marks is how much now? 0025 and that can be displayed. It is an integer value. So what format specifier I should use? %d and here we invoke the function printf. What will happen is this 25 is read from the memory and that will be displayed onto the screen as shown here. Now we have accessed which field? Name field. Then we have accessed which field? Marks field. Now tell me how you access this average field. So here I can write what? P arrow mark average. And this average is float. So here what I write? %f. And I have to invoke which function? Printf. So I write printf. Now tell me what will happen is, what will happen now? P pointing to average means 24.5. That 24.5 is read from the memory and that will be displayed onto the screen. So this is how we can access the members of a structure using arrow operator. Now let us see how to access the members of a structure. First one, arrow operator. It is also called selection operator. What is the second method? We use the combination of a star look here. Here we have P arrow mark name. We have used which operator here? Arrow operator. So instead of arrow, we can write star P dot name, star P dot marks, star P dot average. So whenever we have this arrow operator, we can use what? Dot operator, provided star P is enclosed within parentheses like this. So here, what is the second one? Using dereferencing symbol, that is a star, along with the dot operator also, we can access the members of a structure. And what is the first one we have here? Look here, in place of star P, in place of star P, if you observe, here, if you observe star P, here what is the name? A. So A and star P, they are one and the same. So here star P can be replaced with what now? A. So we know how to access the members of a structure using, one is the dot operator, another using dereferencing symbol and dot operator, and finally using arrow operator. It is also called what? Selection operator. So this is the first one, this is the second one, and this is the third one. I hope we understood how to access the members of a structure. First one using dot operator, second one using dereferencing single line dot operator, and finally using arrow operator. If it is a pointer, most of the time I recommend to go for this syntax, that is arrow operator. Okay, now let us see how to write a program to access the members of a structure. Here we have already wrote the partial code to access various fields. Now all these code must be enclosed within braces like this. And here I write void main followed by, what is the syntax? Void main followed by empty parenthesis. So this is a complete program. Are we using any function here? Yes, we are using printf function. The declaration of printf function is available in one header file by name stdio.h. So go here and write hash include stdio.h. This must be enclosed. This stdio.h must be enclosed within angular brackets. So less than and greater than. Now I hope you understood how to write a program to access the members of a structure. Okay. So here what I can write? A dot, in place of A what I can write? Star P. So instead of A I can write star P like this. See, observe, instead of A I can write star P. Instead of writing star P and a dot, I can use what operator? Arrow operator. I can say P arrow mark, P pointing to name, P pointing to marks, and P pointing to average. So this is the first method. This is the second method using star and dot, using the third method using arrow operator. Okay, now let us see what do we mean by a nested structure. And in the previous classes, I think we have seen what is a nested for loop, what is a nested if statement. What is a nested if statement? An if statement enclosed within another if statement, we call it as a nested if. What is a nested for loop? A for loop enclosed within another for loop, we call it as a nested for loop. Now the question is, what is a nested structure? Now look at this. Let me explain with an example. Suppose we have marks 1, marks 2 and marks 3. 3 marks are there and all are of type what? Integer, and enclose all these marks within the braces, and here I write struct followed by type def. Now tell me, this structure I have defined to have a combination of how many marks? 3 marks, marks 1, marks 2 and marks 3. So here, because of type def, here you have to write the user defined type. So here I write marks. Now once you define a structure something like this, tell me, is memory is allocated? No, memory cannot be allocated for this structure. If I want to allocate memory, then we have to associate this structure with a variable. That can be done something like this. So here I use one variable m, which is of type what? Marks. Now let us see how the memory will be allocated for the structure variable m. Okay, now a block of memory is allocated. Okay, what is the name given for this block? The name given for this block is M. So here I write M. And within this block, memory has to be allocated for how many variables? 3 variables. One is marks 1, marks 2 and marks 3. So here I write marks 1. What is marks 1? It is of type integer. So how many bytes of memory has to be allocated? 2 bytes for marks 1. Another 2 bytes for marks 2. And another 2 bytes for what? Marks 3. So that's how the memory is allocated for the variable M. Okay, now suppose there is another structure which consists of name of how many characters? 10 characters. And then you have USN, and finally you have marks 1, marks 2, marks 3. Now how many fields are there here? 5 fields: name, USN, marks 1, marks 2, as well as what? Marks 3. Name is of type what? Character. What about USN? USN, I can say it is of type integer. What about marks 1, marks 2 and marks 3? They are of type what? Integer. So all these members must be enclosed within braces like this. So here I use a keyword struct, here I use a keyword typedef. Now here what you have to write compulsorily? An identifier, say student. Now the moment we define a structure something like this, memory will not be allocated. If I want to allocate memory, some variable has to be associated with this student. So here I write A is of type what? Student. The moment we say A is of type student, memory will be allocated for the variable A. And here name, it occupies how many bytes? 10 bytes. 10 bytes are reserved for the variable name. Then what we have here? USN is of type what? Integer. Tell me what is size of integer. Let us assume it is 16-bit machine. So 2 bytes will be reserved for what? USN. What about marks 1? It is also of type integer. So 2 bytes for marks 1. And here int marks 2. Another 2 bytes for marks 2. And finally we have marks 3, and here I write another 2 bytes for which variable? Marks 3. Now memory is allocated for the variable M, memory is allocated for the variable S, memory is allocated for the variable S also. Okay, now if you observe, here we have marks 1, marks 2, marks 3, all are of type what? Integer. So here we have marks 1, marks 2, marks 3 of type what? Integer. So what I do? Instead of writing int marks 1, int marks 2 and int marks 3 3 times, let me use this declaration. I will move the declaration here. Okay. Now what will happen? Here there is no variable associated with this structure, so memory will not be allocated for this structure. But look what we have here. Yes, we have. So memory will be allocated for the variable S. What is the first field? Name. What is the second field? USN. USN is of type what? Integer. So USN is of type integer. Integer takes how many bytes? 2 bytes. Now look here. M. The variable M is of type what? Marks. Marks in turn has how many fields? 3 fields. Marks 1, marks 2 and marks 3. So this marks 1, marks 2, marks 3, actually it is a block. What is the name given to that block? The name given to this block is what? The M, the variable M here. So earlier we had marks M, that variable, if it is moved inside the structure like this, so this is basically a structure definition. This structure is inside this structure, so it is a nested structure. I repeat, a structure which is enclosed within another structure, we call it as what? Nested structure. So here M is a nested structure. Okay, now let us see. Now look here, as we declare variables inside a structure, this is one variable, this is another variable, this is another variable. So as we declare variables inside a structure as shown here, okay, or look at this point here. These are the normal variables which are defined inside a structure. So as we declare variables inside a structure can also be declared inside a structure. So here, as we declare two variables, name and USN, as of type char and as of type integer, we can use one more variable m, which is of type what? Marks. So as we declare variables inside a structure can also be declared inside another structure. This is called what? Nested structure. So this is a structure which is defined inside this structure. Now let us look into the definition. Now tell me, as we declare variables inside a structure can also be declared inside a structure. So a structure whose member itself is a structure is what? Nested structure. Look at the definition. A structure inside a structure is called a nested structure. This structure is inside another structure, so we call this as what? A nested structure. I hope we understood what is the meaning of a nested structure. For example, this is a nested structure. Okay. Now let us see how to initialize the members of a nested structure. Now here we have name field and here we have USN, but remember this is the structure which is inside another structure. The variable in the declaration must be followed by what? Equal to sign and followed by data items. The data items that are to be initialized must be separated by commas. Now look here. Here I have a variable s. So s is equal to, first what you write? RAM. Okay, RAM will be copied to this location. Into this field what had copy? USN. So what you write? Say 100 is the USN. And next what we have? Marks 1, marks 2 and marks 3 all are of type what? Integer. Remember, it is a structure. So what I write? I write 25, 24, 23 within the braces like this. So here the data items are to be initialized, must be enclosed within parentheses. So these data items must be enclosed within braces. So this is one field, this second field, and the whole thing is treated as a third field, and all these three fields must be enclosed within braces like this. Okay, now what will happen here? The RAM will be copied into which field? Name field. What is the next we have here? 100. 100 will be copied into which field? USN. So 100 will be copied into USN field. And before that, when we copy RAM, the string RAM always must end with what? Null character. Next 100 will be copied into this memory location. Now here we have, these are three structure members and this is the structure here. So what will happen? First 25 will be copied into this location, 24 will be copied into this location, and finally we have 23 will be copied into this location. I hope now we understood how to initialize the members of a structure. Now the last point is the data items thus initialized. So the data items thus initialized as shown here are stored in memory as shown below. So this is how the data is stored in the memory, and here we have used nested structure. Okay. Now the question is how to access the members of a nested structure. Let us see how to access the members of a nested structure. The data stored in each member can be accessed using dot operator as shown below. Now look here, what is the name given for this one? The name given for the entire block. The name given for the entire block is S. Using S, how you can access this name? I can write S dot name. Now tell me, if I say s dot name, what I get here? Ram I get. So the output will be Ram. Now tell me how you access this field. I want 100. How to access 100? Using the member name and using the variable s. So how you can write s dot usn. If I write s dot usn, what we get here? 100. Now this is the structure. What is the field inside the structure? M is a field. Like a name, like usn, here we have m is also a field. So how you access this field? You can write s dot m. So I write s dot m. But if you take this one, m is the name given for this block. Using this m, how you can access marks 1? I can write m dot marks 1. So here I write m dot marks 1. How many dots we are using here? 2 dots. S dot m. If I say s dot, we get this. It can be m. If I say m dot, we can access either marks 1, or marks 2, or marks 3. So if I say s dot m dot marks 1, now tell me what is the output we get here? 25. Similarly, you tell me how you display this 24. How you display 24? You think and tell me. Using this statement, you displayed 25. Now, how you display 24? That can be done. First, write the variable s, followed by what? Dot. The moment you write dot, you can write either name, usn, or what? M. So, m is the field here. So, write s dot m. The moment I write dot m, either you can access marks 1, or you can access marks 2, or you can access marks 3. Now, tell me, which one has to be accessed now? Marks 2 has to be accessed. So what you write? S dot m dot marks 2. So what is the output we get here? 24. Similarly, to display 23, what is the statement I should write here? S dot m dot what? Marks 3. So S dot m dot marks 3 means I am accessing this field. So what is the data I get here? 25. So 25, I am sorry, it is not 25, it is 23. So 23 will be displayed onto the screen. I hope we understood how to initialize and how to access the structure members or members of a nested structure. Okay, now the question is how to display the data stored in members of a nested structure. S dot name. If I say s dot name, what I am going to get? Ram. To display this, what is the format specifier I should use? The data stored in each member can be accessed using which operator? Dot operator as shown here, and can be printed using printf statement as shown below. So what is s dot name? It is a string. How you display string? I have to use a format specifier %s and then I have to use a print statement. So what is the output we get? Ram. Now tell me how you access usn. How you access usn? S dot usn. It is of type integer. So to display integer, what format specifier I should use here? %d. So here I write printf %d s dot usn. Tell me what is the output I get here? 100. Now here I have s dot m dot marks 1. When I say s dot m dot marks 1, what is the data I should read from the memory? 25. It is of type integer. So here I should use a %d. So if I use this statement, s dot m dot marks 1 means 25. 25 will be displayed onto the screen. What about 0024? 0024 can be accessed using s dot m dot marks 2. It is also of type integer. So here we use a %d. Now tell me what is the output we get here? Output will be 24. What is the last one we get? 0023. How you get 0023? Using s dot m dot marks 3. Again I have to use a format specifier %d and then I have to use a printf statement. Now tell me what is the output we get? 23. So I hope we know how to what is a nested structure and how to initialize a nested structure, how to access the members of a nested structure, and then how to display the members of a nested structure using printf statement. Next, how to read the data from the keyboard and how to store the members of a nested, how to store the data read from the keyboard using the members of a nested structure. I think that we can discuss in the next class.